Now, based on this, please write it down. Please write down this fifth point as well. In continuation to these 4 points, please write down this fifth as well, and then we'll do the question. Addition or removal of pure solid does not affect equilibrium. When you have copied fifth, please try the example written in front of you.
So the first one, it will not affect the equilibrium.
Okay. The question says AgCl solid plus H2O liquid gives you Ag plus aqueous plus Cl minus aqueous ions. The question is what happens to equilibrium if A, AgCl solid is added. So a reactant is being added in solid form. What will happen? Give your answers individually, please. Come on fast.
So backward direction.
Okay. Daksh is saying backward direction when AgCl is added. Okay. Niranjan is saying, again your answer, child, Niranjan.
So there will be no change in the equilibrium.
Okay, there will be no change in the equilibrium. Okay, two very different answers. Nikhil, your answer?
Sir, I think no change.
Again?
So no change in.
Okay, no change. Charan, your answer? Come on.
I did not read the fifth point, so it will be no change only.
Why did you not read the fifth point? Did I not make you write the fifth point? Isn't it?
I have not written the fifth point.
Oh, write it down fast. Come on.
I have
See, we
written
are
it
going.
now.
Sir, A bit there will be no change, no effect.
Okay, but okay. So why are you, Charan? Why are you so late in answering this?
Sir,
Isn't it?
I was not
Could have
able to
answered.
hear you.
Oh, all right. Yes, obviously, I have told you addition or removal of pure solid does not affect the equilibrium, and AgCl is a pure solid, obviously, or all solids are pure solids. If we are taking the chemical name of chemical compound, any chemical compound solid, they are pure. Okay. So when we add them, there is no change which is going to happen in the equilibrium. Now, the B part. Now the
The
B part.
backward direction.
Okay. H2O liquid is added. Okay. So Daksh is saying the backward direction. Let's take answers from others as well. Come on, Nikhil and Charan, your answer. Niranjan, your answer. Anything you might think?
The forward direction.
Forward direction. Okay.
Forward.
Forward direction. Okay. Yes, Charan.
Sir, forward.
Okay. Now let's ask the reasoning behind it. Okay. We'll first ask Daksh. Daksh, your reasoning behind the answer backward. How come the reaction How come the equilibrium will shift backward if more water is added? Please explain.
So when a product is added in a reaction, it shifts to the backward direction.
And are you sure H2O is on the product side? And not on the reactant side?
No, sir, it's a reactant side.
Oh, what is going on with you, child? What is going on with you? Huh? Who is disturbing you there? So H2O is on the reactant side for sure. And now Daksh will say it will shift in the forward direction. Now all your answers are forward. No, but I am more interested in the reasoning part of it. Okay. Yes, Niranjan, your reasoning, please. Why will it shift in the forward? Yes, Niranjan. Please explain your answer. Nikhil, can you explain your answer?
So since more reactant is added, it will go to forward direction, right?
Okay. Okay. All right. And Charan, any other explanation? No? Okay. All right. Now, see, what should I tell you? See, the answer is forward direction. Okay. But not for that logic which you are giving me. Why? Because H2O liquid is a pure liquid. Okay. Similar to AgCl solid, H2O liquid concentration also does not change. If you add more water, the concentration of H2O will not change. It is same because it is pure. Similar to the solid AgCl. Niranjan, are you there?
Yes, sir.
Okay. Child, I was asking you your reasoning of your answer. Please state your answer again and then the reason.
So in the forward direction.
The reason?
So because if the reactant is added, then the equilibrium in the reaction will favor the forward direction.
Okay. All right. So you all have applied the logic which you should have applied, although the logic is wrong. I'll tell you what is the correct logic. The answer you have approached is correct. Answer is forward, but not due to that logic. Okay, logic is something else. I'll explain you what is that logic. Now please observe. AgCl solid and H2O liquid, both of their concentrations does not change if you add more of them. Why? Because AgCl is solid. Okay, whenever a solid is added, the concentration, the activity does not have any effect. Okay, same is the case with the pure liquid. If you add a pure liquid, the concentration does not change. Okay, I mean you can see if you drink one glass of water and if you drink 2 glasses of water, the concentration of water is not changing at all. The concentration of water is constant. Why? Because it's there is nothing mixed in that. Okay, had there been a salt mixed in the water and then you mix water, then the concentration of the solution will change, but the concentration of water will never change. Okay, now how are we going to see this question? How are we going to solve this question? Now please observe. The concentrations which can change are Ag plus and Cl minus only, not AgCl because it's solid, not H2O because it's a pure liquid. The concentration only of Ag plus and Cl minus can change. Now please tell me, if you add more of water, can I say you are diluting the solution? Please tell me. Can I say that? Adding more of water dilutes the solution.
Yes,
And
sir.
yes, and the concentration of Ag plus and Cl minus reduces. I can also say that. the concentration of Ag plus NCl minus reduces. Can I say that? Please tell me.
Yes.
Nikhil, Niranjan,
Yes, sir.
Charan? Yes? Okay, okay. Are you getting it? Yes? Nikhil, Niranjan? Anyone?
Yes, sir.
Getting it? Okay. All right. All right. So now, when the concentration of the product has been reduced, lechatelier will say, I will nullify the situation. And when the lechatelier will nullify the situation, therein the equation has to move forward to produce more of the products, to
Sir,
increase
Nikhil
the
will not be able
concentration.
to join the class today.
Acha, acha. All right.
Sir,
What
he
seems
has
to be the
power
problem?
cut. Power cut.
Power cut. Okay, his area is experiencing too many power cuts. Why are you not experiencing so many power cuts as Nikhil? What is the reason?
Sir, I don't stay
Uh,
in his area, sir.
okay. All right. All right. His area is in the danger zone. Okay. All right. That is too bad for him, because what we are discussing is very interesting today. Okay. All right. So since the concentration of the products has dipped, the reaction will move in a forward direction. Okay. So I have summarized this in the explanation here of the B part. Niranjan, can you read this out? B part explanation.
Addition of pure water is a very interesting case since it dilutes the concentration of all reactants in the above reaction. Equilibrium moves in forward direction because the concentration of products decreases on addition of water.
Yeah. So addition of pure water is a very interesting case since it dilutes the concentration of all reactants and products. Okay, both reactants and products, obviously. And then in the above reaction, equilibrium, this is equilibrium moves in forward direction because the concentration of products decrease on addition of water. Okay, so what I am saying is generally addition of water will affect the concentration of all the components, whether reactants or products. But in this particular case, in this particular reaction, since the reactants are very, very unique, reactants are solid and a pure liquid, their concentration cannot change. Their concentration is constant, even on the addition of water. Okay. Therefore, the only effect which will be observed will be on the product side. Product side, the concentration will reduce. Okay. And hence the reaction will move in a forward direction. And this is a classic example. Please write it down with the explanation. Then we'll move ahead. Nikhil, are you here? Nikhil, are you here?
Yes, sir. Power. Sir, there's a power cut in my place. So
Okay,
I from
so
another device.
okay. All right. Let me kick somebody out and then you can copy. Just a moment, please. What's up, Bubs? I tell you what's up, Bubs. Just a moment. Yes, please. Please write down the explanation of B. Here is the explanation of B. a very good example to demonstrate how water or any other pure solvent, okay, it is not only the case with water, any other pure solvent will have the similar effect. Whenever you add more of a pure solvent, the concentration of that pure solvent will not change, will never change. It is constant. The only thing which will change is the decrease in the concentrations of all other reactants and products. Okay. But in this particular case, very unique case, in this example, the reactants, none of the reactants concentration will change. Why? Because one of the reactant is solid. Solids activity is always constant, taken to be 1. And also of pure liquids. Again, activity is taken to be 1. So their concentrations will not change. The only effect will be on the product side. So more you dilute it, the more the reaction will go in the forward direction. A very unique example.
Stadium.
Okay. Let me know when everybody has done. Daksh, Charan, done?
Done, sir.
Yes, sir.
All right. Let's move ahead. Now, in the first part, lechatelier told us something about how do we see the change in the equilibrium point when the reactant or product is altered with either increased or decreased, added or removed. Okay, now we are moving to something else, and now lechatelier will be applied when volume or pressure is changed. Okay, now this part of change in volume or pressure can only be seen effect upon the effect can only be seen upon the reactions which involve gases and not at all the reactions which involve solutions or liquid state. Okay, because the pressure affects only the gases part. Okay, so now there is there is a caution which I have written in the red. Niranjan, can you read the caution part? I hope I am audible.
Yes, sir.
Okay, Charan, you read the part. Caution.
Changes in equation will only happen in
Equilibrium.
will
Equilibrium.
happen in equilibrium if delta Ng is not equal to 0. If delta Ng is equal to 0, then no change in equation can occur no matter what.
Okay, so that EQN is equilibrium here, although I agree that sometimes I write it for equation as well. So in order to cut it short, I wrote it EQN, but In this chapter, it is for equilibrium. Let me read it again for you. So the question part which I have written is, changes in equilibrium will only happen if delta Ng is not equal to 0. Now, delta Ng is not equal to 0. What is delta Ng? Delta Ng is the...
Sir,
Yes, please.
Nikhil is in the waiting room.
Oh, I'm so sorry. We applied the waiting room and we forgot Nikhil. Nikhil, are you here now?
Sir, my power came back.
Oh, great, great. So, Nikhil, we are seeing the application of lechatelier when volume or pressure is changed. In the second part of applying lechatelier, in this particular part where we change volume or pressure, this effect only happens on only those reactions which involve gases and will never happen where the solution reactions are taking place. Okay, so only for the gases part. Now, there is a question written in red. I'll read out the question for you again. Changes in equilibrium will only happen if delta Ng is not equal to 0. Now let's let's first understand what's written here. We need to first understand what is delta Ng. Can anybody tell me what is delta Ng? We have studied before. Anyone? Don't you remember what is delta Ng? Change in...
Like C plus D minus A plus.
Yes. Correct. Change in gaseous moles. Change in gaseous moles. You are correct. C plus D minus A minus B. Okay. So change in gaseous moles means you add the moles of not the moles but the stoichiometry, I should say. You add the stoichiometric coefficients of the products, that is C and D, and then subtract the values of stoichiometric coefficients of the reactants, that is A and B. So delta Ng is always equal to C plus D minus A minus B. Okay, so now it is saying that if delta Ng is not equal to 0, then only any change will occur in the equilibrium position. Otherwise, let's see what is written for otherwise. If delta Ng is equal to 0, then no change in equilibrium can occur no matter what. So if delta Ng is equal to 0 in a particular reaction, if you calculate that and there are any changes of pressure or volume, whatever be the case, no change in equilibrium will occur. Okay, so this is a important thing. So please copy the heading. Second, we are seeing the application of lechatelier. Second application on disturbing the volume and pressure. Also write the caution part. Then we'll move to the theory part of this. Just copy it. Let me know when you have. Let me know when you have done.
Written, sir.
Okay, I hope you are writing only the red part, till the red part.
Yes, sir.
We're
Okay.
done.
All right. All right. So let's see the next part. So we have done the caution. Now we'll understand if delta ng is not equal to 0 and we know the changes will happen. Now we'll see how will the changes happen. Now let's read this. Nikhil, can you read this in order to understand from here?
Yes, sir.
Okay.
In order to understand what changes occur, we must understand that whatever change reaction can do is in the terms of moles. Either more moles or less moles will be finally produced than before.
Okay, wait.
Volume is directly proportional to number of moles.
Okay. Now you need to understand something. You need to go into the shoe of a reaction. Imagine that you are a reaction. Now imagine, what do you have in your power? Okay. If somebody disturbs you, if somebody is trying to tinker with you, what can you do? You have very limited options. What you can do is either you can go forward or backward. That's it. That's what you can do. Nothing else. And we have discussed that you are having delta ng not equal to 0. So in one of the directions, either in backward or in forward, the number of production of moles would be more. And in the other direction, the number of the production of moles would be less. Isn't it? If I try to combine the caution and this point, they together, what they mean is the reaction can only change the number of moles. That is the only discretion a reaction has. If delta ng is not equal to 0. If delta ng is equal to 0, that reaction is useless. That reaction can't change anything at all for pressure and volume change. Okay. So we are talking only for delta ng is not equal to 0 here. You will have to check for each and every question whether delta ng is equal to 0 or not equal to 0. If it is not equal to 0, then this point will come very handy. This point says, in order to understand what changes occur, we must understand that whatever change a reaction can do is in the terms of moles. So it is saying that reaction can only change its number of moles. That's it. It can either increase it or either it can decrease it. Now, we know that volume is directly proportional to number of moles. More the number of moles, more is the volume. So this thing, more the number of moles, more is the volume, is the key part. Is the key part in this chapter, in this particular topic of lechatelier. You will be using it a lot. More the number of moles, more is the number of volume. Less is the number of moles, less is the volume, even the vice versa. Less volume, less moles, more volume, more moles. Okay. So if somebody tells you that I have reduced the volume, you will say the reaction will go in a direction where the number of moles will become less. Okay. But before writing that, please write this black para which I have written to you. Then I will tell you the points, sub points, what you have to do, and in what situation. Okay, just write this para and write volume is directly proportional to number of moles. Please copy it.
So once I'm leaving and joining because my net is interrupting. So please let me
Okay,
in.
okay, sure. Let's check whether he has rejoined. No, he has not. Let me check again. Oh my God, not even now.
So done.
Okay, just a moment, let me check. No, his network is creating a lot of issue. Has everybody done?
Yes, sir.
Okay. Now we'll see specific points detailing how we should, what changes we should do in a reaction, or how to predict where a reaction will go in different cases. Now, the first point. The first point says on increasing the volume of the container or decreasing the pressure, let's do one thing. Let's rejoin again. Okay, because Daksh is also trying to rejoin, and we'll have to rejoin again, obviously in 3 minutes. Let's do it right now. Okay, please rejoin. Oh, he has entered. Daksh, rejoin. Daksh, Daksh, rejoin Daksh. We are ending the meeting. Please rejoin.
Okay, sir.
Hmm.